Imagine standing at the edge of everything, not just the edge of the Earth, or the solar system, or even the galaxy, but the edge of the universe itself. Picture it, stars stretching endlessly in every direction, nebulae glowing like cosmic lanterns, galaxies spinning in silent ballets of gravity and light. You keep traveling farther beyond clusters of galaxies, past voids so vast they dwarf anything the human mind has ever tried to measure. And then you reach the edge. But here's the question, the one that breaks the brain open like glass. If the universe is expanding, what is it expanding into? What lies beyond the edge of everything? The moment you try to picture it, your imagination collapses, because how do you imagine nothing? Not empty space, not a black void, not darkness. True nothing, no space, no time, no dimension. A place, or rather a non-place, where even the concept of place doesn't exist. Our minds revolt against it because the human brain evolved to survive in forests, savannas, and rivers, not to comprehend infinity. Yet here we are, daring to ask a question that even Einstein, Hawking, and modern cosmologists wrestle with. The universe, as far as we know, began 13.8 billion years ago, with the Big Bang. A single point of unimaginable density, smaller than an atom, exploded into everything. Space, time, matter, energy, the entire fabric of reality unfolded from this singularity. But here's where the paradox begins. When we hear Big Bang, we imagine an explosion inside empty space, like fireworks in the night sky. But scientists tell us that's wrong. The Big Bang wasn't an explosion inside space. It was the creation of space itself. Space and time were born in that instant, which means there was no outside for the universe to expand into. Yet today, we know the universe is expanding. Galaxies are racing away from us, their light stretched into red by the Doppler effect. The farther they are, the faster they move. Hubble's law, discovered in the 1920s, revealed this cosmic truth, and the latest measurements from the Planck satellite give us an expansion rate of about 67 kilometers per second per megaparsec. That means for every 3.26 million light years of distance, a galaxy appears to move 67 kilometers per second farther away. The fabric of reality itself is stretching. So the haunting question returns, stretching into what? Imagine blowing up a balloon. The rubber expands, and dots drawn on the surface move away from each other. From our everyday perspective, we say the balloon expands into the surrounding air. But here's the trick. The universe is not a balloon in a room. It's more like the two-dimensional surface of the balloon itself. If you're an ant crawling along that surface, the balloon doesn't expand into anything. It just gets larger, and the distance between you and everything else increases. That's what cosmologists suggest our universe is like. Except, unlike the balloon, our universe isn't two-dimensional. It's three-dimensional space expanding, with time woven in, forming a four-dimensional fabric. But then comes the next terrifying thought. A balloon is embedded in a higher dimension. Its surface is two-dimensional, but it exists in a three-dimensional world. Is our universe like that too? A three-dimensional surface floating inside a higher dimensional box. Physicists call this the brane theory, short for membrane, an idea from string theory suggesting our universe might be a 3D brane embedded in a higher dimensional space. If true, then perhaps our universe is expanding into dimensions beyond our comprehension. But what if not? What if there is no outside? Cosmologists say the question might be like asking, what's north of the North Pole? The pole is the furthest north you can go. Beyond it, the concept of north ceases to exist. Similarly, outside the universe may be a meaningless phrase, because the universe includes everything: space, time, dimensions, energy, matter, and the laws of physics. By definition, nothing can exist outside it. But this answer feels unsatisfying, doesn't it? It gnaws at it, because if the universe is finite, how can it not have a boundary? And if it's infinite, how could it have started from a finite point? The ancient Greeks wrestled with these ideas too. Aristotle believed the universe was eternal, with no beginning and no end. The Stoics thought it went through cycles of birth and destruction, an eternal cosmic heartbeat. Modern science gives us measurements and mathematics, but the awe and confusion remain the same. Today, telescopes like James Webb peer 13.5 billion years into the past, almost to the dawn of time. What they see are galaxies already formed, stars already burning, structures that force us to rethink what the beginning even means. And then there's inflation theory. In the first fraction of a second after the Big Bang, 10⁻⁻�36 seconds, the universe is thought to have expanded faster than the speed of light, ballooning unimaginably. In less than a blink, something smaller than a proton grew to the size of a grapefruit, and then kept expanding. But if inflation happened, what stopped it? And if inflation can occur once, could it happen again, spawning not just our universe, but countless universes in a grand multiverse? This is where things get dizzying. Because if multiverse theory is true, then our universe isn't expanding into nothing. It's expanding into something bigger, an infinite sea of other universes, each with its own laws of physics, its own constant, its own dimensions. Some might have no stars. Some might collapse instantly. Some might be teeming with life, unlike anything we can imagine. And we just happen to exist in one, where the laws allow galaxies, planets, and consciousness. But let's pause. Let's stand. Right now, the observable universe, the part we can actually see, is about 93 billion light-years across. That number itself feels impossible. Remember, the universe is only 13.8 billion years old. How can it be larger than 13.8 billion light-years? The answer lies in expansion. While light has been traveling toward us for 13.8 billion years, the space between has been stretching, carrying those distant galaxies farther away. That's why the edge of what we can observe lies much farther than the age of the universe suggests. And beyond that edge, unseeable, lies the unobservable universe, possibly infinite. Now imagine this. You're floating near the edge of the observable universe. You look out, and beyond the faint afterglow of the cosmic microwave background, there's nothing you can detect. No light, no signals. But is that nothing the same as nothingness? Or is it simply a barrier of time and light? A horizon beyond which even photons haven't had enough time to reach us? In that case, the universe might go on forever, and what we call the edge is just the limit of our vision, not of existence itself. And yet, the question haunts us. Is space infinite, or is it curved back on itself, like the surface of a sphere, where traveling in a straight line long enough would bring you back to your starting point? Einstein's equations allow for this possibility, a closed universe, finite but unbounded. Imagine a 3D version of Pac-Man's worlds, where moving off one side brings you back on the other. If true, then the universe doesn't need an outside to expand into. It simply stretches its own fabric, endlessly reshaping the space within. But then, what about time? Did time have a beginning? And will it have an end? Or is it infinite, looping endlessly? If the universe expands forever, galaxies will drift apart until their light no longer reaches each other. Stars will die. Black holes will evaporate. Trillions of years from now, only cold particles and fading radiation will remain. Cosmologists call this the heat death of the universe. But in that frozen silence, might expansion itself spark something new? Could the void collapse, birthing another Big Bang, another universe, another cycle? The deeper we dive, the stranger it gets. Quantum mechanics whispers that empty space isn't truly empty. It seethes with virtual particles flickering in and out of existence, a bubbling quantum foam. Could our universe have emerged from that foam, a fluctuation that inflated into reality? If so, then maybe nothing is never truly nothing. It's the potential for everything. And yet, the question still grips our imagination. If the universe is expanding, what is it expanding into? Nothing? Everything? Something beyond comprehension? What if the answer lies not in space, but in consciousness? Human perception evolved to ask these questions. We are the universe trying to understand itself. Atoms from stars now thinking about infinity. Maybe the boundary we seek is not out there, at the edge of galaxies, but within us. the limit of what the human brain can conceive. To break through, we may need a new kind of mind, artificial or evolved, capable of holding ideas that to us feel impossible. And so, here we stand at the edge of everything we know, staring into the abyss of what we cannot. The universe expands, and with it, so does our curiosity. Every new telescope, every new theory, every new question, pushes that boundary further. We may never find an outside, but in searching, we discover something even more profound, the boundless depth of mystery itself. And perhaps that's the secret. The universe doesn't expand into space, it expands into wonder, into the limitless imagination of those who dare to ask what lies beyond. Imagine standing on the edge of nothing, no ground beneath your feet, no stars above your head, just an endless black ocean that doesn't even have waves. Now imagine being told that this void, this silence, this nothingness is not real, because outside the universe there is no such thing as space to step into, no such thing as outside to even imagine. And yet, the universe is expanding. That fact is not a matter of belief. It's been proven through the redshift of galaxies, through Edwin Hubble's observations in the 1920s, and later confirmed with extraordinary precision by the Hubble Space Telescope and the Planck satellite. Galaxies are racing away from us, some faster than the speed of light itself, driven by a mysterious force we've come to call dark energy. But if there is no outside, what is the universe pushing into? How can something expand if there is nothing beyond its edges? This is where the human mind falters, where even language begins to betray us. The problem lies in how we visualize. We think of the universe like a balloon. The rubber stretches, the surface expands, and dots drawn on the balloon drift further apart. It's easy to imagine the balloon's surface as the universe, and the air outside as the nothing it grows into. But the analogy collapses the moment we remember there is no air, no outside, no higher dimension of space beyond the cosmos that we can point to. The balloon model is useful for intuition, but fatally misleading if taken too literally. Because the expansion of the universe isn't like a balloon swelling into a room. It's more like space itself stretching, with no room beyond it. The galaxies aren't flying outward into some external void. They are carried apart as the very fabric between them lengthens. And the more we measure, the stranger it becomes. When the James Webb Space Telescope looked deeper into time than ever before, it revealed infant galaxies, tiny, compact, impossibly luminous, formed only a few 100 million years after the Big Bang. But here's the paradox. Those galaxies today exist tens of billions of light years away, farther than light itself should have been able to travel in the lifetime of the universe. Why? Because the space between has expanded faster than photons can cross. In other words, expansion is not a movement through space. It is the creation of new space itself. The universe is not moving into anything. It is growing from within, like a flame consuming fuel, yet with no container around it. This is where the human imagination collides with the limits of physics. If nothing exists outside, then asking what lies beyond is like asking, what's north of the North Pole? It's a direction that doesn't exist. The universe is not expanding into something, it's expanding into itself, redefining space as it goes. Yet even this explanation leaves us unsatisfied, because our instincts demand boundaries, edges, and so scientists have probed deeper, turning to geometry and higher mathematics to paint pictures that words cannot. One idea is that our universe is finite but unbounded, curved like the surface of a s. If you travel in one direction long enough, you could in theory loop back to where you started, without ever encountering an edge. In this model, the expansion isn't into emptiness, it's simply the increase of distance across the whole surface. But there are other models too, far stranger. Consider the multiverse hypothesis. What if our universe is just one bubble among countless others, all suspended in a higher dimensional foam? Each bubble expands, not into void, but into a greater sea of existence beyond our perception. In some variations, these universes can even collide, leaving faint imprints on the cosmic microwave background, the radiation left over from the Big Bang. Some scientists have even claimed to see such scars, though the evidence remains disputed. If true, then the question changes. Our universe isn't expanding into nothing, it's expanding into a larger reality, where many universes are born and die like waves on a cosmic shore. But even that doesn't fully answer the deepest mystery. What is this larger reality? What laws govern it? Does time even exist there? Or are we clinging to human concepts that mean nothing at that scale? Some theories suggest space and time themselves are emergent properties, like temperature or pressure, arising from more fundamental entities, quantum information, strings, or something even more alien. If that's true, then asking what the universe expands into is like asking what sound expands into. It's not the right framework. The universe isn't inside of something else, it is the something. And yet a chilling thought lingers. What if expansion is not infinite? The rate of expansion today is accelerating, but cosmologists debate what that means for the future. If dark energy remains constant, the universe will expand forever, galaxies slipping away until only blackness remains. If it strengthens, space could rip apart itself in a big rip. Atoms torn asunder in a cosmic cataclysm. If it weakens, gravity could pull everything back in, collapsing into a big crunch. Each possibility changes how we understand the very nature of existence. But none of them give us a simple outside to point toward. Here's the unsettling truth. When you step outside on a clear night and look up, you're not peering into space the way you look across a field or into an ocean. You're staring into the expansion of reality itself. Those galaxies are not receding into darkness. They are dragging darkness into being as they go. The universe is not moving into nothing. The universe is making the nothing. Space is not a stage where the play unfolds. It is part of the script itself. And the more we unravel it, the more we realize we may never know the stage beyond the stage. The silence behind the silence, the void that may or may not even exist at all.